It works. Hello, everyone, and a very warm welcome to our session of today. My name is Martine, and it's a pleasure and privilege for me to introduce our four speakers of today. They are all leaders in sustainability in their own way, practicing sustainable in business and also as an everyday way of life at Teijin. Let me first tell you something about Teijin to set the scene. Teijin is active in 4 business fields. In total, 169 companies. The business fields are materials, healthcare, IT, and fibers. We employ over 22,000 people across Europe, Asia, and the Americas. Our roots go back for more than 100 years, as we were the first to commercially produce rayon fiber in Japan. But as much as we have built on a legacy of innovation, leadership, and global expansion, our focus has always been forward-looking, as we set out to build a better world for tomorrow. With this in mind, we are taking great strides to deliver on our vision, enhancing the quality of life in harmony with society and with our employees through the development and application of sustainable technologies. Our top priorities at Teijin are climate change mitigation and adaptation and the achievement of a circular economy. We aim to reduce our CO2 emissions by 30% in 2030, and by 2050 we want to be internal net zero. Our brand statement, human chemistry, human solution, is very much the focus of the presentations of today. The presentation will be followed by a question and answer session with you as an audience, because we are here for you. And if time allows, we also have a panel discussion prepared where we can delve further into the details of the challenges, the issues, but also the solutions of sustainability. So to get to know you a little bit better already as an audience, I would like to ask you, where are you from? You are from the Netherlands. Anybody else from the Netherlands? Oh, hello, nice. And you are from? You are from Japan. Okay, anybody else from Japan? Who? Ah, more. Anybody from Germany? Hello, nice to see you. Anybody from the US? Okay, very nice. So we have a very diverse audience here. That's nice to know. So for now, let me introduce you to our first speaker. He's a man who, throughout his distinguished career, has followed the less traveled path to find new ways to connect people and technologies. And in his current role at Teijin, he is there to facilitate open innovation and to foster sustainability projects. Please welcome Ton de WEIJER.
Thank you very much, Martine, and welcome everybody. My name is Ton de WEIJER. I am leading the Environmental Solution Division in Teijin. Teijin is a global company with very strong Japanese roots. Yes, I have to switch to the next one. And you can see it here. This is actually a very ancient Japanese tradition, which is very relevant for us now. In Japan, it's called kintsugi. And I would like to explain a little bit more about that, because in the West, when we drop an item of pottery and it shatters, well, what do? Yeah, sweep them up, the broken pieces, and throw them away. But this is actually what you see here on the slide. That is a result of what kintsugi tells us. So it says we should gather the pieces together to mend them with gold or silver. And then all the flaws and imperfections, they suddenly become visible. But the original usage is still there, and it adds value into beauty. So rather than throwing them away, we repair it for recycling and use. That's also why in Teijin we believe that kintsugi is a perfect metaphor for sustainability. And it inspires us to find smarter, better, and stronger ways of healing and mending our planet. Then the next slide. Well, you see a guy here, and the name of this person is Edwin ter Velde. Actually, he was a person I met in 2017, just before we had our centennial celebration in Teijin in 2018. And he gave up all his business, his small companies and so on, to prove that waste does not exist only if you change your mindset. Because waste is waste because we define it as waste. Actually, the molecules of the waste, as we all may know, do not change so much. Still, I think they have the inherent value. And he wanted to prove that by sending a solar-powered vehicle to the South Pole made from recycled plastic. And we partnered with him because we find it an interesting challenge, not only for the partnering itself, but also to learn from him. How can we make the change towards a recycling, reduce, and recycle structure? So at Teijin, these reduce, reuse, and recycle, they drive us. And that's what inspired us to partner with him. And actually, on the next slide, I will show you the result of what we have done. This is Union Glacier in Antarctica. That is where the mission started. I hope that now the movie will start. Yes, South Pole, still 1,100 kilometers away. Here you see the result of our partnership. Solar-powered vehicle, 8 kilometers per hour maximum speed, not so fast, but it works. And we used, the center was made of recycled polyester 3D printed products. What we also did is we designed a tire concept, and we desired it, actually never been to the Antarctic plateau, but only simulating the conditions. So it was a high risk for us as Teijin to do that, because if that failed, the whole mission failed. So we took responsibility. We used Tenax carbon fiber to reinforce the structure, and because there's a lot of ice, sharp ice pins, we used Twaron underneath. Also, we had polycarbonate self-heating glazing to ensure the good light. And as you see, these wonderful pictures and these wonderful images show that the partnership was a success. We managed to do so. They survived 30 days on the Antarctic plateau without the use of any fossil fuel. Now, I would like to come to the next slide and tell you a little bit more about what Teijin can do for you. At Teijin, we strive to implement human solutions through human chemistry. And this means that we harness our expertise in designing and to developing composite materials with a clear goal of reducing the environmental impact. And in line with that, we are very happy now here today to showcase our latest composite solution in a variety of fields, including aerospace, automotive, and renewable technology. Let me just introduce a few examples of applications that we are currently working on. But more than that, I really would like to invite you to come to our booth to talk to the experts directly, to know much more about these applications and your needs and how we can partner up. In this slide, in the center slide, you see floating wind platforms. In the shallow North Sea, it's not necessary strictly to have these floated platforms, because we can drill the piles directly in the sea. But in a country like Japan, with the deep seas, there is no possibility to do wind harvesting from seas, except if you do it via these platforms. And actually, we use Aramid with its properties like low creep, low weight, high strength, long life, to anchor these platforms strongly to the bottom of the sea. And it is a clear advantage to doing that for deep sea applications. That's one example. Another example, and I see it's on the right up slide, that is the subsea power cable reinforced with Aramid. There we solve another issue, because also in deep sea you have to put these cables to the ground. And if you have very deep seas, the weight on itself of the cable becomes the restriction. So using steel is no alternative, also not for the corrosive properties. And there are examples already in the world where these applications are really put into practice. For instance, to connect Greek islands. On composite side, let me see on the left bottom side. Yes, we use innovative thermoplastic composite material that combines the resistance, durability, flexibility, and recyclability. And we have developed a material that can be manufactured into very complex shapes within only a minute cycle time, and has been adopted in, for instance, the pickup box of the General Motors Sierra Carbon Edition. And for commercial and military aircraft, helicopters, UAVs, you can use Tenax carbon fibers to keep the world flying. And we are a leading manufacturer, as you may know, of carbon fibers, and our products can be found in a variety of applications in aerospace and other applications. So next time, maybe when you're taking a flight and looking out of the wing, yeah, the chances are quite big that you are looking at one of our products. Now I come to my last slide for this presentation. We really would like to invite you to work with us, because the journey of sustainability is something that not a single company can do by themselves. So the partnering is extremely important. And we know that composite materials are stronger in their bonding than individual materials alone. So that's also why we utilize that. And we know that it's true for humans too. So we have to join our forces on this common mission. And as our brand statement suggests, the potential of human chemistry and the quest of human solutions is maximized when the interaction of the people, products, and services combine new value. So this is an invitation to you to join us and to work together on solving the issues. We embrace innovation and exploration. It's not an easy way, it's a bumpy ride. But that's why we have to partner up. So let's work together, let's connect, let's bond our composite strength and energies to find human solutions to the challenges for this beautiful planet. I thank you very much for the listening. Thank you.
Thank you, Ton, for opening our eyes and minds to what sustainability means at Teijin. And it doesn't mean just doing what's good and right for the business, but it means doing what's good and right for the world. For our next speaker, this has long been his natural instinct, as he is an accomplished windsurfer and sailor. He wants to make sure that the material he uses on the waves are strong, resilient, and safe enough to do the job. So you can really say he knows the ropes. And that also applies today, where he dedicated his professional life in working with Aramids that can be used for mooring lines, but also to reinforce the hulls of fast-racing sailboats on our ocean waters. The use of Aramids in maritime industry is just one example of the application of a very versatile product. So please welcome a leader in sustainability who makes sure that Teijin Aramid becomes the best high-performance fiber company for the world. Jan Roos.
Thank you, Martine. I'm really happy to be here this afternoon to discuss with you sustainability. My name is Jan Roos, Director of Sustainability within Teijin Aramid. And if I go to the next slide, you see a few pictures of our Aramid products. We sell, in fact, 3 types of Aramids, and Ton already gave quite a good introduction to them. Aramids are never sold as such. They're always used in a product of our customers, either composites, mooring cables, a reinforcing panel, a truck tire, many different applications. But in all cases, they are used as a reinforcement to make products more strong, more lightweight, more durable, more impact resistant, and these materials are also good against heat and chemicals. And in that sense, they already have a very sustainable role, because in the function where these materials are used, they can replace traditional materials, or they can make applications possible which wouldn't be possible without these products. And they are often very sustainable. We have done life cycle modeling and CO2 emission calculations, comparing a product that had been reinforced with Aramids compared to that a product reinforced with traditional materials. And in many applications, you see a clear advantage of the use of Aramids. Even to such an extent that with only a few applications, we can show that the CO2 emissions saved in the use phase, they outweigh the CO2 emissions in the production phase of our products. So the use phase is really important for us in terms of sustainability. Still, we use fossil raw materials and we use fossil energy to produce our products. And that's where we also want to make a change. We have a strong program on energy transition. We want our plants to run on sustainable energy. And we are developing a circular technology toolbox, together with partners, I should say. And this toolbox should allow us to come to a fully circular Aramid chain. Our ambition is to be fully circular, and for that you need a lot. Just to explain this graph a little bit, this picture, the bottom is, you could say, the traditional linear world, where we use oil-based raw materials to produce polymer, to produce fiber. Some of it is used to produce pulp, and then it goes into the application at our customers. When the products reach end of life, they're either landfilled or incinerated. That's a waste, really a waste of a good product. So we want to close the loop. And we can only do that by developing together with partners, and that's really the crux. We need to do collecting of materials, sorting, cleaning, and getting them back in the right quality for reuse. As a matter of fact, we already have one recycling technology running already for 20 years, which is the yellow arrow here. That's mechanical recycling, where we produce pulp. Pulp is used in automotive applications, like brake pads, where it replaces asbestos. So in that way, it's a very good application. Still, you can consider it as a downgrading, because we go from a yarn to a pulp. So our ambition is also to go from yarn to yarn. And those are the blue and the green arrows. In the case of the blue arrow, we call it respinning. If the material that we get back and that we clean is very pure, you can mix it with our normal polymer, our virgin polymer, and that mixture can be reused to make a yarn. This is a technology that we developed already on laboratory scale. It runs well. And now we are upscaling it to commercial scale. And we expect to have a yarn with recycled content on the market by 2025. Still, we also think that not all material that comes back from the market will be that clean that we can use it for respinning. And that's why we're also developing the green route, which is depolymerization. The Aramid polymers have the nice property that they can be depolymerized into the original building blocks. Those can be cleaned by chemical distillation and other kinds of cleaning technologies to produce the monomers in pure form, and then we can reuse them to make polymer and yarn. That's our final goal, to develop that technology, but it's not yet that far. The blue technology is more far developed, and I'll show that on the next slide, where one of our research co-workers, he developed this technology for us. We start on the left side with a feedstock, which can be end-of-life material. Then we do cutting, shredding. We make short material. We can blend it with polymer and do spinning again. Like I said, this is a technology that we are currently upscaling to commercial scale. If you look at this total picture, then for us, you might even say the most challenging part is to get the material back in a clean enough quality for reuse. That's where the biggest challenge is. And we cannot do that alone. We need partners. We need to work with our existing partners in the value chain. We need to work with new partners in the value chain to get this done. And as a matter of fact, for me, that's a call to action also for the audience this afternoon. That please work with us, come to us, and let's discuss if you have technologies or if you have material available that can be given a second life in the Aramid world. Thank you.
Thank you, Jan, for sharing your insights and expert knowledge on this. And you've shown us that the pathway to sustainability lies in finding the balance between the business needs and also the needs of the planet. Now let me introduce to you a man who knows a great deal about finding and maintaining balance. He's a passionate cyclist, and he knows very well what carbon fiber can make as a material difference in the pursuit of sporting excellence on two wheels. He also came to learn that sustainability and recycling in the group has some similarities. Both require innovative materials and technology, and it also requires teamwork. Today he will talk about the reduction of CO2 emissions in the production of carbon fibers and about recycling of those. Please welcome Markus SCHNEIDER.
Thank you, Martine. So, my name is Markus SCHNEIDER from the Carbon Fiber Business Unit, and I'd like to show you now our efforts in terms of carbon fiber materials in regard of sustainability. And although our materials are totally different, I feel extremely well with my colleagues within one Teijin, and we really can join our efforts, not only bringing sustainability to the market, but also to work on our ideas to get a circular economy. As said already by Ton, we supply carbon fiber direct to the customers and help to get sustainability there, as for instance shown in the wind energy market, where our materials are needed when you have a corrosive load, as in the on the offshore market, and you also need stiffness in the wing blades. But also if you look, for instance, in aerospace, if the aircraft is in the air, you have extremely low temperatures and you need carbon fiber materials to really have a stiff wing, to have an aerodynamic flight operation mode in all times. So you see that we supply a lot of sustainability to the customers, and I now like to show you our efforts, our internal efforts, to get down our energy and also then the CO2 reduction. What you see here is mainly our process in 3 steps. We buy a fossil monomer from the world market, use this together with the solvent, and then we have our spinning equipment and the stretching, and we make a precursor yarn out of it, which has almost the same dimension than the carbon fiber, but it consists of many other non-carbon atoms which we have to get rid of. And then we supply this carbon precursor to our carbon fiber production lines, which are always close to the end users, also there to avoid logistic with the materials to these final customers. And what you see here is the process in principle. We use the precursor within an oxidization and a carbonization step. Then we apply a surface treatment, and finally you have a carbon fiber. And unfortunately, out of 1 kg of precursor, we only get 500 grams of carbon fiber. The remaining material does not just disappear. We need a lot of energy to run our waste gas treatment with natural gas, and we have to supply nitrogen in the ovens to avoid any oxidization. All these needs a lot of energy, and this is the current solution within our plant at the moment. And then finally, we use the carbon fiber for some downstream materials, as for instance for textile reinforcement or thermoplastic materials, where we make good usage of our material knowledge and supply to the customer direct the wanted material. And now we have a plan. How to get renewable and green carbon fibers. First approach is that we really have to work on our reduction of energy. And as said, we use at the moment energy to stretch the material, and there we want to become better with renewable energy to get this portion of our CO2 footprint down. And the next step is, as said already, that we have to work on the carbon fiber production itself. Everybody thinks that we need a lot of energy for oxidization and carbonization to heat up the ovens, but already now we use heat recovery from our waste gas to run this part of our processes. So this is already done since a couple of years. But what we try to apply in the next step is that we want to produce our nitrogen on a new facility, which is totally run by renewable electricity, and there we really want to get down our footprint. And this will then proven evidence within an energy management system based on ISO 50001. And of course, finally, we have approved LCA, which then can be shared with the customers. So these are the basic steps in the near future. And a step where we also work on, and we expect the first carbon fibers within this year, is to exchange the monomers from a fossil base to a sustainable basis. And there we then have a carbon fiber material which follows the standard route, but with reduced energy. And then we will have the first real green carbon fiber. This will be followed by ISCC Plus certification to show to the customer that we are able of handling such kind of material. And then, of course, final step is also to talk about recycling and upcycling of all the materials which we have in parallel to our production processes, where we always have cut-off materials or side cuts and so on. And as you might be aware of, Teijin is already the leading supplier of short fiber products in the world, where we supply a lot of different short fiber materials with different sizings, thermoplastic, water-soluble, even nickel-coated if you need some electrical conductivity. And our approach will be to use our reinforcement materials, where we have the cutoff, as shown here, or even from our customers, and then make pelletized carbon fiber out of it, for instance, for compound applications or other applications. And the benefit from our group is that we are totally aware of our feedstock. So we can absolutely know which type of carbon fiber is in the material, which give us less costs in producing and hopefully a higher quality product in the end. So thank you for this, and I'd like to hand you over.
Thank you, Markus, for showing us the very link between cycling and recycling. In both cases, they help to make the world go round. And that, of course, is key to setting in motion the ideal of a circular economy, which is such a vital component of the sustainability strategy at Teijin. Our final speaker today knows a great deal about this, as he earned his doctorate for his study in easily recycled thermosets. But his passion for environmentally friendly and conscious science goes way back to his school days, where he won a prize at a science fair for a project to use microorganisms to clean up oil spills. His current focus is on enhancing the sustainability of fiber-reinforced composites. And today he will explain how life cycle assessment helps to draw a baseline for further improvements. Please welcome David KRUG.
Thank you. Thank you. Hi, everyone. My name is David KRUG, and I'm a senior material scientist in the Advanced Research and Development Department at Teijin Automotive Technologies. We're headquartered in Auburn Hills, Michigan, in the United States. It's a city that has a very long and proud history of serving the automotive industry and being real pioneers and progress makers. So in that tradition, we're right in the driver's seat as a world leader in the formulation, design, and manufacture of glass fiber reinforced composites. So we focus on providing automakers with lightweight, durable composites that offer design and packaging flexibility. And what this does is it helps to kind of set the pace for greener, cleaner vehicles on the road to tomorrow. So you can see some examples of our composites here. And what's important to note is that our lightweight composites improve the fuel efficiency in internal combustion engine vehicles, and they can increase the range for electric vehicles. We serve other key markets, such as agriculture, where we actually have an example of where we use a soybean oil-based resin in our composite. In line with the Teijin brand statement of human chemistry, human solutions, at Teijin Automotive Technologies, we've adopted a holistic approach to sustainability, where we try to provide environmental value solutions at every step of the life cycle of our products. So wherever the road may lead, Teijin Automotive Technologies is in it for the long haul. And so what that means to us is that the entire life cycle of our composites, from raw material extraction to product manufacture to end of life. So through this holistic approach to sustainability, we actually calculate the climate change impact of our products. And we do this by weighing up every input and output along the way. To date, we've actually conducted 2 life cycle assessments, or LCAs, and these serve as both a baseline for best practices and you know, a metric to measure our future progress against. So in the chart behind me there, where we operate as a manufacturer is right in the center, outlined in the black box. But thinking holistically means thinking outside of the box. And what that means to us is making sure to exercise our influence over every stage of the process, from material selection to part design. And so by doing this, we're really living and working by the philosophy that the whole must always be greater than the sum of its parts. While it's comforting to talk about sustainability as a philosophy or as a long-term ideal, what if it was possible to actually quantify the kind of impact that your product has on the mitigation of climate change? So that's the kind of question that we set out to answer with our life cycle assessment studies. And this graph here, what we're looking at the product manufacturing process step. So the blue bars is it's one of our structural composites, one that would be used for a truck box material. And the green bars represent an appearance composite, which means it has a very high quality surface finish, and it would be used for exterior body panels. To begin with, our composites are formed into a sheet that can then be compression molded into very complex shapes. And what we found was that our composite sheet, the climate change impact of it was actually 65% lower than an aluminum alloy sheet. Now, both the aluminum alloy sheet and our composite sheet still needs to be formed into the final part. That means additional energy, additional materials. But if you look at the right side of the chart, what you will see is that even our fully formed and finished composites that go out the door, they have a lower climate change impact than the aluminum alloy sheet that is unformed. So when you start to apply this kind of sustainable thinking, you can start to see the difference that your products can make in the real world every day. So you've heard my colleagues talk today about sustainability, and when they're talking about it, they're often talking about it in circles. And that's important because, you know, every link in the circle of value that drives our business is a link that makes us stronger together. And so when Teijin Automotive is thinking about decreasing the environmental impact of its products, it's also thinking about increasing and improving the sustainability of our supply chain. So to that end, we are always on the lookout for suppliers that share our vision, share our values, and can help us achieve our sustainability goals. At the same time, we're also seeking closer collaboration with on the product development and design process with our OEM customers, the ones that want lightweight, high strength weight to ratio composites that will also provide environmental and sustainability solutions. And the collaborations, they don't just make our products stronger, they strengthen all that are involved. And it's important because, right, we're all on this road to change together. And what we've come to realize is when you reach the end of the road, it's really not the end at all. As one cycle of value ends, it's an opportunity for a new cycle of value to begin. That's the power and the promise of recycling. In-house, we have developed a patented chemical recycling technique that allows us to recycle our composites, and we can recover the fiber and the matrix. The situation right now, the current scenario, is that our composites end up in the landfill with the end-of-life vehicle. And just like the chemical recycling technique that I talked about, there are other better options. Another one that we've explored through teamwork is collaborating with IACME, the Institute for Advanced Composite Manufacturing Innovation, and they have thoroughly researched thermal recycling. In that innovative process, the decomposed polymer can actually be captured and used as a fuel to run the process. And that also provides the opportunity to recover the fiber and fillers and give them another life. Another interesting end-of-life scenario is the co-processing in cement route. And what that does is it leverages the huge infrastructure of the cement industry to reuse composites as both a fuel and a feedstock. And the result there is quite cool. It can be a product that has a lifespan of up to 100 years. So I just want to close, I guess, by saying that at Teijin Automotive Technologies, we're taking this holistic approach. We're seeking for collaboration because we're all on this road to change together, and we can all help strengthen each other. Thank you.
Thank you, David, for sharing your very important work with us, and may you go on and inspire the next generation of environmental scientists to go on in your footsteps. And with that note, we go on to the Q&A session. So, questions from the audience. Who can I give the mic to ask the first question? It's a very shy audience today, or it was all super clear. No questions? Then I have a plan B. Oh, there's one question. Thank you.
Hi, Olivia Schutstra, Dutch, working for GE in supply chain sustainability. I read in the Composites article that you might have an internal carbon price. I don't know if you have anything more that you could share about that. I'd be very interested.
I think you did best.
It's about the
internal carbon price.
Internal carbon pricing, yes. Yeah, yeah.
Well, your mic is still,
do I have to use this one? Okay, yeah. Yeah, indeed. We used the methodology of internal carbon pricing to motivate internal investments to go towards more sustainable investments. I do not know the figure exactly, but recently we have heightened the internal carbon pricing. I think now something like €100 per, 100, eh? Yeah. And that really stimulates to come up with investment proposals that are more sustainable. And that is what we're really trying to do, and it's absolutely also practiced in the boardroom. I've been in many decision investment applications in the boardroom, and I see every time at least that question is asked and it's triggered and questioned. Perhaps it's not enough to do. It's not enough to do internal carbon pricing only. It's not an excuse to do something, but it motivates our people to think about sustainability and to have a higher chance of success that the internal investments will be granted. So that's how we do it. Yes.
Okay. Other questions? Okay. Gentleman from the Netherlands.
Good afternoon.
Does it work?
Yeah. Hello?
Yeah.
Yes.
I think it was Dr. Roos. You were talking about recycling of Aramid in the Netherlands. You implied that you would be interested in other people supplying scrap material to you to be recycled. Is that correct?
Yeah, I don't know if this one works. Hello?
Yeah. Yes, it works.
Yeah, does it? Okay. Yes, indeed. I mean, On the one hand, we need material, and on the other hand, we need technologies.
Okay.
So both are interesting for us, indeed. Yeah.
I mean, like bulletproof vests or more the fibers and the raw materials?
Yeah, well, bulletproof vests in most cases contain rather clean materials. As a matter of fact, we are already recycling those to a large extent to reuse into the mechanical recycling. I think the challenge is to come to recycling technologies for materials that are really embedded in a matrix. Okay. Like in a composite or in a flexible composite like a rubberized product. Those are, I think, the challenging materials that we need to separate.
I understand. I have a few other questions, but maybe I should address them to you privately with regard to, let's say, the technologies required with recycling of Aramid in the acid environment type of thing.
Excellent.
If I may do that.
Let's join at our booth later on.
Okay, wonderful.
Yep.
Thank you very much.
Thank you. Thank you.
Yeah, so all our speakers will be available at the booth after this presentation, so feel free to drop by and say hi and have a more, indeed, one-to-one conversation about the topic. Any other question? You now have time to think about it, so maybe something pops up. Okay, if not, I have a plan B, of course. So we prepared some statements for a panel discussion, and I will put out 3 here, and then we vote which one we want to have the discussion about. So the first is the urgency of the climate crisis requires radical, transformative changes to our economy and society. What are your thoughts on this, and how can collaboration and innovation help facilitate these changes? So that's number 1. 2, the only way to truly address the climate crisis is to eliminate the use of fossil fuels entirely. How does Teijin approach this issue, and what role do you see chemical companies playing in the transition to a more sustainable energy system? That's 2. Then the third one, chemical industry faces now countless headwinds from all the fronts. How can we, all players in the industry, work together to keep our industry sustainable first, so that we, as an industry, can develop and deliver the sustainable innovation that supports the future of the planet and society? So who votes for number 1? Okay, and who for 2? Okay, that's the winner right now. Number 3. Okay, we go for number 2. So the only way to truly address the climate crisis is to eliminate the use of fossil fuels entirely. So who from this panel is willing to ask respond first? Okay, Markus.
So maybe I start from the carbon fiber business unit. First of all, our first approach is to get a new precursor, meaning a new raw material for acrylonitrile. And there we're really strongly working on it, and our idea is really to get an additional green carbon fiber parallel to our standard materials. And this then also will be supported by using green electricity, which is easy, and the next step is really to get rid of the natural gas for our waste gas treatment. There we talk about other types of gases, as for instance biogas, or as soon as available, green hydrogen. And of course, the thinking goes much further to think of, do we still need this carbonization process to come to the same mechanical approach in the end? So I think that Teijin has one of the unique approach that we are totally integrated from the monomers to the final application, and there we really have the chances to incorporate all our knowledge to get rid of all the fossil-based materials or energies.
Maybe I'll take it over for the Aramid business. We have plants in the Netherlands and in Japan and in Thailand. So the situation looking at energy is of course different location by location. But focusing for instance on the Netherlands, our plants are currently running with cogeneration units on natural gas, which is for a long time was, yeah, you could say the best technology there was. But of course now we need to make a second step. And for one, electricity, like Markus also mentioned, I think changing to renewable electricity is not such a big step. although it will be scarce. And there is one issue in the Netherlands, is that congestion on the electricity grid is already playing a big role. So there I think there is also a huge role for electricity companies and for our government to make sure that there is enough capacity on the grid for all the companies to make the transition towards renewable electricity. On the other hand, we are also using steam, high pressure steam, so you could say high pressure heat, high temperature heat. And high temperature heat is probably the most challenging one, because their electricity is often quite an expensive source of energy. So we are looking into mechanical vapor recompression and other heat pumps. If you have a coefficient of performance, say a factor of 4, then often electricity is well, good enough to supply heat. In other areas, you need to find other sources. We're looking at hydrogen. Unfortunately, at the moment, still very scarce and very expensive, therefore. So also we're looking into biomass, but then that really has to be sustainable. And there, I think what we also really need is a good discussion within society. What kind of solutions are acceptable and what not. So we're also trying to engage other partners in society to discuss these issues and see, okay, what would be a sustainable solution really? And I think that's the way forward. And I think we cannot wait. We have to act quickly. If you look at the big industry, we are only one investment cycle away from 2030. So we really need to do a good job now and make steps. And I think we really need to do it all. There is no one magic bullet, I think. You really need to do it all. And we need government, we need infrastructure, we need companies all to work together here. And I see this in my hometown, in my home country, the Netherlands. I see this slowly developing. It is developing, but I think we can accelerate it.
Okay, thank you. There were also quite some votes for the third option. So how can we become sustainable as an industry that we can also deliver sustainable innovation that supports the planet? So, David, do you want to comment on that one?
Sure. I have something I'd like to say about the third one, right, and how we can work together. I think for the composites industry, two things that we really need to do is educate and advocate. And I say that because from the commercial or business side, I think we would probably all agree the customer is always right, maybe. But on the scientific side, I don't know that you can always say that 100% of the time. And it's our responsibility to already tell them about all the great things that composites can do and why they should be one of the sustainable materials of choice and put it high on the list. And that's not just the responsibility of Teijin, which we do accept and take happily, but it's really everybody in the room and here at the conference, right? We need to advocate for ourselves and get our message out there about composites.
Okay, thank you. Ton?
Perhaps very shortly, I see time is running out, but actually I want to connect 2 with 3, because both of it gives tremendous innovation opportunities for all of us. If we look at nature and the inventiveness of nature, how can we apply these kind of concepts to develop new materials, new composites, and so on? So, yeah, apart from that, I would say that it's a big innovation opportunity to look from another side, from another angle, from this crisis. Because I always believe you need a crisis to reinvent yourself, and I think we have to look at the opportunities.
Thank you very much. And with that, we come to the final end of this presentation and panel discussion. Thank you very much, audience. You were very nice to work for, and you are welcome at our booth in Hall 6, stand number G28. So Hall 6, G28. Okay, thank you very much. See you.
Yeah.